Coding is a way of simplifying statistical calculations. When data are coded, different statistics change in different ways. So, in my previous statistics video, we learned how to code data in an ungrouped data set. Now today, let's take a look at how coding affects data given in a frequency table. So, as I said earlier, if data are coded using the formula y equals x minus a over b, where a and b are constants, let's say, that are given in the question, then the mean of the coded data, that is y bar, equals to the mean of the original data, which is x bar minus a divided by b. And the standard deviation of the coded data equals the standard deviation of the original data divided by b. Now, let's take a look at this example. The lifetime t in hours of 70 light bulbs is shown in the following frequency table. Now, the data coded using y equals x minus 1 over 20. Estimate the mean of the coded values, which is y bar. Now here, the data are presented in a group frequency table. So, in order to code the data, we need to find the midpoint for each of these class intervals. So, I'll add an extra column to this table to make it more clear. Now, the midpoint x. So, when coding data in a group frequency table, we use the midpoint. So, I've already covered about class boundaries, class width and midpoints in one of my previous statistics video. If you want, check it out for more details. Now, as you can see here, the data has no gaps. So, if we take the first row of 20 to 22 hours, this is the shorthand form of writing t is greater than or equal to 20 but less than 22. As the data has no gaps, the class boundaries for the first group is 20 hours and 22 hours. This is because since the data has no gaps, the class boundaries are the numbers of the class. And hence, the midpoint is 1 over 2 times 20 plus 22 equals 21. So, the midpoint x of the first group 20 to 22 hours is 21. Now, let's work out the midpoints for the other groups. So, 22 to 24 hours, that is, t is greater than or equal to 22 but less than 24. Since the data has no gaps, the class boundaries for the second group are 22 hours and 24 hours. And hence, the midpoint is 1 over 2 times 22 plus 24 equals 23. Now, 24 to 26 hours. That is, t is greater than or equal to 24 but less than 26. The class boundaries are 24 hours and 26 hours and hence the midpoint is 1 over 2 times 24 plus 26 equals 25. 26 to 28 hours. The class boundaries are 26 hours and 28 hours and hence the midpoint is 1 over 2 times 26 plus 28 equals 27. 28 to 30 hours. The class boundaries for the fifth group are 28 hours and 30 hours. And hence the midpoint is 1 over 2 times 28 plus 30 equals 29. Now, since we know the midpoints for each class interval, we can use this formula y equals x minus 1 over 20 to code the data. Now, coding the data using the midpoints of each class interval, y equals x minus 1 over 20. So, for the first group, the midpoint is 21. So, the coded data value is y equals 21 minus 1 over 20 equals 20 over 20 equals 1. Now, to code the rest of the data, y equals 23 minus 1 over 20 equals 1.1. Y equals 25 minus 1 over 20 equals 1.2. Y equals 27 minus 1 over 20 equals 1.3. Y equals 29 minus 1 over 20 equals 1.4. Now, since we know all the coded data values, we can use this formula to calculate the mean. So, for data given in a frequency table, the mean equals the sum of the products of the data values and their frequencies divided by the sum of the frequencies. So, first I'll add all the frequencies together, then it's 3 plus 12 plus 40 plus 10 plus 5 equals 70. Now, using this formula for the coded data values, y bar equals 3 times 1 plus 12 times 1.1 plus 40 times 1.2 plus 10 times 1.3 plus 5 times 1.4 divided by 70 equals 3 plus 13.2 plus 48 plus 13 plus 7 divided by 70 equals 84.2 over 70 equals 1.20 hours. So here we divided the sum of the products of the coded data values and their frequencies by the total frequencies. Now find an estimate for the mean of the original data. Since we know the mean of the coded data, we can use this formula to get an estimate for the mean of the original data easily. So, the data coded using the formula y equals x minus 1 over 20 and hence the mean of the coded data y bar equals x bar minus 1 over 20. So, we can rearrange this formula to get x bar, that is the mean of the original data. So, rearranging the formula gives us 20 y bar equals x bar minus 1 x bar equals 20y bar plus 1. And hence the mean of the original data x bar equals 20 times 84.2 over 70 plus 1 equals 25.1 hours. Now estimate the standard deviation of the coded values. So we can use the formula for calculating the standard deviation for data given in a group frequency table. I've already covered about calculating the standard deviation for data given in a group frequency table in one of my previous statistics videos. If you want, check it out for more details. So, the standard deviation is the square root of the mean of the squares minus the square of the mean. Now first, let's find the sum of the products of the coded data values and their frequencies, that is sigma fy. So, multiplying all the coded data values with their respective frequencies gives us 3 times 1 plus 12 times 1.1 plus 40 times 1.2 plus 10 times 1.3 plus 5 times 1.4 equals 84.2. Now, let's find the sum of the products of the coded data values squared and their frequencies, that is sigma fy squared. Then it's 3 times 1 squared plus 12 times 1.1 squared plus 40 times 1.2 squared plus 10 times 1.3 squared plus 5 times 1.4 squared equals 3 plus 14.52 plus 57.6 plus 16.9 plus 9.8 equals 101.82. Then the standard deviation of the coded data values equals the square root of sigma fy squared over sigma f minus sigma fy over sigma f squared. Now we know the total frequencies add up to 70, then sigma f equals 70. Then it's the square root of 101.82 divided by 70 minus 84.2 over 70 squared equals 0.0878 hours. Now, estimate the standard deviation of the original data. Since we coded the data using the formula y equals x minus 1 over 20, the standard deviation of the coded data equals the standard deviation of the original data divided by 20. So, we can easily find the standard deviation of the original data by rearranging this formula. Then, the standard deviation of the original data equals 20 times the standard deviation of the coded data. Then, 20 times the square root of 101.82 over 70 minus 84.2 over 70 squared equals 1.76 hours.